When you click a button to generate an image or ask a question from your serverless AI function, you expect it to happen instantly. Instead, the screen spins for 30 seconds, sometimes even longer. This isn't a slow internet connection or a bug in your code. It is a fundamental architectural conflict between how cloud providers save money and what users need when they run large models on demand. Today, we examine why serverless GPUs suffer from massive cold starts and how shifting to a hedging strategy changes the entire engineering equation for latency reliability versus cost efficiency. The pain point you feel as a developer is real, but your assumption about its cause might be wrong. You likely think that if you configure the function correctly or use a faster network, the delay disappears. In reality, this lag is an architectural inevitability of loading massive models onto fresh hardware for every single request. When a serverless GPU provider receives no traffic, it shuts down the instance to save money. The moment a new user triggers an inference, that empty machine must wake up from scratch. This involves initializing complex drivers and streaming gigabytes of model checkpoints from remote storage into limited video memory before any processing can begin. The scale problem is severe for large language models because traditional caching fails in multi-tenant environments where GPU memory capacity is scarce. Research indicates that 85% of inference functions receive no more than one request per minute. This creates a brutal dilemma. Keeping GPUs warm for these rare invocations ensures instant response times, but wastes money on idle hardware, while leaving them cold destroys the user experience with delays lasting up to several minutes because remote storage cannot feed video memory fast enough. You are forced into a binary choice where you either pay for capacity that sits unused or accept latency spikes that make your application unusable during peak moments. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The industry has responded by moving away from simple load-and-run models towards sophisticated scheduling algorithms, but the most impactful shift is not just technical optimization, it is a strategic rethinking of how we handle requests. Academic research and pilot deployments have introduced concepts like execute, while load, pipelines that fundamentally change data movement across networks. Instead of waiting for an entire model to finish loading before starting work, systems can multicast model data while the GPU begins processing incoming requests immediately. This approach allows inference to start before the full transfer completes, reducing tail latency by up to 5 times compared to standard baselines where every request waits for a complete download. Other frameworks are decoupling storage from compute entirely to solve this bottleneck. Platforms that utilize late binding and dynamic swapping keep models in main memory rather than forcing them onto GPUs until the exact moment of execution. This reduces GPU provisioning costs by roughly 70% while maintaining near-native execution speeds, though it requires complex interference, aware scheduling to prevent different functions from fighting over limited resources. By treating model loading as a background pipeline task rather than a blocking operation for every single user request, engineers can achieve an 11.3 times reduction in function duration compared to existing solutions that load data sequentially. This leads us to the core strategic pivot, why hedging serverless providers improves cold start P95 latency from 117 seconds down to 30 seconds without requiring you to keep expensive hardware running all day. The solution is not merely tweaking configuration files or optimizing code snippets. It is an architectural trade-off between cost efficiency and latency reliability that demands a new mental model for system design. If your application requires sub-second P95 latency, the most robust engineering judgment often involves running multiple providers in parallel to ensure one responds quickly, accepting higher complexity in exchange for guaranteed performance. Practitioners must stop treating cold starts as a bug to be fixed and start viewing them as a fundamental constraint of the hardware-software interface. When you hedge across different serverless environments, you are essentially betting on diversity rather than relying on a single provider's initialization speed. This approach leverages distributed caching strategies where requests are assigned only to nodes where the model checkpoint is already cached in near GPU storage hierarchies. The result of such smart scheduling can achieve latency reductions by a factor of 10 times to 200 times compared to state-of-the-art systems that rely on standard cold start behaviors. turning what was once an unusable lagfest into a reliable production service. The career judgment here is clear. Understanding that serverless for AI does not mean instant means you must stop looking for magic buttons and start designing for the reality of hardware initialization times. Engineers who can architect systems using these patterns will be better equipped for production-grade AI deployment because they understand that reliability requires redundancy, not just faster code. The choice is no longer just about cost versus performance. It is about latency reliability as a first-class citizen in your system architecture. By implementing hedging strategies and adopting execute-while-load pipelines, you move from being a victim of cloud provider economics to an architect who controls the trade-offs that define user experience. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.